We'll start by looking at the general form of an exponential function. We have f of x equals a times b to the x, that x being the key, being the exponent. And if we look closely, you can see the domain, and you can see our exponential function goes up to the left and up to the right. The domain, this is going to continue going left, so our domain will always be everything on the left, which is negative infinity, and of course less than x, less than, and to the right, it's going to continue going forever, so to infinity, and we can write that as all real numbers, probably the faster way to do it, so let's try to do that. And then the range is a little different. You see I have this dotted line here, this dashed line. This dashed line represents the asymptote. The asymptote is that barrier that it never goes below or never goes above, depending on how this is faced. In this case, it never goes below the asymptote, which is part, you'll discover later, is part of the equation, part of the function. And it's that barrier that the line will never go below it. Where that line is, we're gonna just pretend this one is at 1. And if that's the case, the entire function is going to be above 1. So we'll write that as y is greater than 1. Now the reason we don't put equal to is because it never will actually reach that. That's why it's called the asymptote. So the range is going to be either, in this case, y is greater than whatever the asymptote is. But it could also be, and you'll see later on that these functions can go the other direction, it could be y is less than whatever the asymptote is. So it's going to be important that you can determine what an asymptote is and how you can determine it by looking at the equation. The first exponential function we'll look at is when b is greater than 1. For example, y equals 5 to the x. So the b is greater than 1. When this happens, you're going to have what it's called an increasing function. This graph, or this function, will look like this. It'll start low, and then at some point begin going upward. So you have an increasing when it's greater than 1. And finally, the asymptote for the one like this, since it's going upward and increasing, would be y is greater than whatever the asymptote happened to be. Next, we'll look at it when b is less than negative 1. So that means like negative 5x, y equals negative 5 to the x. This is one that will be decreasing. In this case, it'll start at a high point and then eventually start going downward, like so. So it looks like that, going from left to right, decreasing. And the asymptote for one like this would be y is less than whatever the asymptote happened to be. For our next one, we'll look at when b is between 0 and 1. It means it's positive, but it's a number less than 1. This is another one that will also be decreasing. And the equation might be something like y equals 0.5 to the x. So that number 0.5 is between 0 and 1, but it's positive. In this case, it's going to start high and eventually level out at the asymptote. So it is another decreasing one, like we said. And for one like this, the range would be y is greater than whatever the asymptote is. And for our fourth one, we're going to have when b is between negative 1 and 0. In other words, it's a smaller number, but it's negative. So like y equals negative 0.5 to the x. This one's going to start low and work its way up before leveling out. And again, it is increasing. And whatever the asymptote is, its range would be y is less than the asymptote. Now for the notes in your packet, we're going to go ahead and, since I changed it at the last minute, we're going to change this. Just go ahead and cross this out. We're not going to worry about that, but we're going to look at the bottom section. But these three graphs, don't worry about them for now. But let's look at the bottom. So we'll start here by looking at this part by summarizing what we already talked about. when you're talking about the domain of a exponential function, unless we have some sort of restriction on it, like some reality, it's going to be basically negative infinity is less than x is less than infinity. Whether it goes like that or goes like that or whatever direction it goes, it's going to go from left to right. It's going to continue going left to right, so it's not going to change. So remember, you can also write that as all real numbers. Now the range is going to be different. Only part of the graph is going to be considered. You know, if you're looking at one that looks like this, everything below in this area is not going to be included in the range. So basically, you're going to look at the asymptote, where the asymptote is 0, whatever it is, and it's either going to be greater than or it's going to be, that's a less than. It's either going to be less than or it's going to be greater than whatever the asymptote is. Now, it won't be including, so it won't be greater than or equal to or less than or equal to. It'll just be greater or less than, because remember, the asymptote is that boundary line where it reaches, but it doesn't quite get. And that goes into our next statement. The definition of an asymptote is a boundary line. Now, in each one of these classes, I had somebody line up and try to touch the wall with their feet, and they never could do it. That's because the asymptote is something that you can never reach, or in this case, sometimes passes. So if we look at the graph here on this paper, you have an asymptote right here, and I'm going to put a little dotted line. That asymptote is y equals 0. The asymptote itself is that line, so it's y equals 0. The domain of this line, because it's going to keep going this way, it's going to keep going out that direction, is going to be negative infinity is less than x is less than infinity. And the range, since it's above this line, it's going to be y is greater than, and in this case, y is greater than 0. It can't be y is greater than or equal to, because again, it does not actually reach it, even though when we zoom in, you can't tell. We know by definition that it will never reach it. So it's y is greater than 0. So we have a range, which is always above or below the asymptote. We have a domain, which is almost always going to be all real numbers. And our asymptote is that imaginary line that is a boundary.